Is it?
Yeah,
Wow.
I took the dog out and I looked and I was like, oh my gosh, it's 59. It's beautiful.
Yeah. I actually got brave and went for a run this morning because it wasn't below 20 degrees out. It was just truly amazing. So yeah, nice stuff. So it's a sad day for folks to be missing because we're starting something new today. We're going to start looking at statistics. That first statistics homework is not due until the 15th, which is, I guess, that's Monday. Um, uh, but in addition to doing that homework, I'm going to ask you to please read in the textbook or the virtual textbook, chapter 12, section 1, because a lot of what we're going to start discussing today is an interesting read in the textbook, and it'll add a little bit more detail. Before we start looking at statistics, one, does anybody want to look at anything back from the probability chapter? Any homework, anything from the notes? Does anybody have questions on anything?
I have a question regarding the project.
Yes, ma'am.
Did you release a due date and I just was unaware of it, or like on Blackboard there's no due date for project 2?
I think I verbally gave you guys a due date, and now me being me, I don't remember what date I gave you. I think you handed it out on Friday.
I think you said it was due Monday, the 15th.
Yeah, I was just gonna say, I think it's due the 15th. So project 2 is due the 15th. If you're having issues with it on the 15th, we'll see how that goes. Has anybody started looking at the project? This one's probably maybe less time consuming because you don't have to survey people, but in terms of the math that you're doing, there's a little bit more math involved than the set one. So you start looking at it, go to that website, pick out game that you're interested in, and if you need help setting up that table for expected value, do not be afraid to ask. And I guess because I'm asking you folks to read this section of the virtual textbook before we get started, I'm going to ask, does everybody know how to get into the virtual textbook? Does anybody want me to walk you through that process?
I haven't
Yes,
accessed that
please.
yet, so that would be good.
Okay, to get into the virtual textbook, what you want to do, actually, I'm going to exit out of this because I'm going to go into the virtual textbook for part of class today. There's an article that I want to show you and some examples from the book that we'll look at, if not today, on Friday. So you're going to go into My Math Lab. Don't go into the assignments, go into the course home. When you go into that course home, sing the Jeopardy song or something to kill time while you're waiting for your internet. I like to go to this multimedia library. I think if you want to, you could also go to chapter contents, but I go to the multimedia library. And so I'm looking for you to go to chapter 12, statistics, and I'm looking for you to go to section 1, which is on sampling, frequency, distribution, and graphs. I'm asking you to go to the multimedia tab. As I look at all of the choices here, though, please notice they have videos to help you. They have activities, animations, PowerPoints, all sorts of things besides just the textbook. And so when I hit find now, do you notice down at the bottom, they give me this link. And when I click on that link, sometimes it takes me 2 clicks. Sometimes when I first click on it, it yells at me and says it doesn't like the internet in my home. And yeah, Blackboard does that to me somewhat frequently. I hope all of you have realized that if the first time you click on something Blackboard, it says, no, 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 we don't want to let you in. Your best bet is to backtrack and try again. And 9 times out of 10, when Blackboard yells at me that it doesn't want to let me in, if I backtrack and try again, it does let me in. And so this is chapter 1. It's a neat little story about MASH, and it introduces some of the ideas. And again, we're going to be looking at a page of this in a minute. So did everybody see how to get there?
Yeah.
Okay, then let's start looking at this new unit that deals with statistics. When I do that, I'm going to try to slant this surface a little bit to make it easier to write on. So am I correct in assuming that while this is a new unit for us, you have all heard the word statistics before?
Yeah.
What is
Yeah.
it? What is statistics?
We need to bring life to this place, am I right?
Oh, that was interesting. But what is statistics? Any ideas? What does it deal with when you hear statistics? What's it all about? Silence. Okay, I guess statistics is related to the sounds of silence. Now, statistics, are you guys familiar with the idea that it's the study of data?
Yeah, and it's like analyzing too.
Yeah, it's analyzing it. It's got all sorts of different parts. In the study of data, it also involves the collection of data. And that's why I want you to read the chapter 12, section 1, because they go into a little bit more detail on the collection of data than we will in class. And I think you would just benefit from reading that. When we look at statistics, we'll talk in a little bit about methods of collecting data. There's good ways and there's bad ways. But statistics we're going to find is broken into 2 parts. There's descriptive statistics. And when I talk about descriptive statistics, I'm talking about organizing, representing, summarizing, the data. So we're going out, we're collecting data, and we've got all of this information. And it's all there. Part of what we do in descriptive statistics is take that information, put it in an orderly fashion, make a nice visual display of it, and try to summarize it. Try to say, okay, this is the information that I got. After descriptive statistics, there's also inferential statistics. And that's with inferential statistics, we look at the description, the summary, and we use it to generalize and draw conclusions. Yeah, I mean, there's this idea that we've got all of this data out there. We can organize it and look at it and see what the data says. But taking it to that next step, taking it and saying, but what does it mean? How does it influence what I'm looking at? Can I draw conclusions from it? So we're going to mostly focus on descriptive statistics, but we will look at the tip of the iceberg in that idea of inferential statistics when we start looking at something that's called the normal distribution. Some of you might have done a real little bit with the normal distribution in high school, but I'm not certain that everybody's had an opportunity to look at it. I don't know if I've mentioned before.
Excuse me.
Go ahead.
I think you forgot to record.
Oh, Lord. Thank you.
You're welcome.
No, it says we're recording.
Oh, it doesn't show on my end. Okay. Oh, yeah, there it is. Okay, I'm sorry.
No, I appreciate that because, oh my heavens, my 3-hour nighttime 106 class, there was one night where I forgot to hit the record and I felt so sorry for those folks. Okay, so inferential statistics. So this course was written, initially contemporary math, the course was written to help people who don't have the strongest math background prepare to take our statistics class. Because in our statistics class, you don't necessarily need an algebra-based review, but some of the topics that we cover, the sets and the probability, and now the part of statistics that we're looking at would help somebody who's going to follow this class with the introductory statistics class or higher level statistics class. In this class, we're going to mostly look at descriptive statistics. In the full statistics class, you spend much more time on those inferential statistics. So when I look at statistics, I start talking about a population. And the statistics, in statistics, the population is the set of everything that's being considered. Everything. So, for example, I might be doing a study and I'm wondering how math impacts the lives of college students in New York State. And so my population would be all of the college students in New York State. Or I might be doing a study on automobiles, American-made automobiles. And so there, my population would be all of the American-made automobiles. So usually you think of population being people, and in some instances it is, but it isn't always. So let's say, for example, I want to study all the college students in New York. Would that be feasible? Would it be feasible to send something out and expect responses, or to feel like you could go ahead and talk to every single college student in New York State? I'm thinking that my head explodes at the idea. I think just in Buffalo alone, there has to be at least 10 different colleges, and then you start adding, Niagara County, and you go around the state. There's hundreds of colleges in New York State. There's too many to actually feel like you can go and reach out to everybody. Yeah.
Yeah.
And so then we instead look at a sample. And a sample is a subset of the population. And so the way in which we choose the sample is that idea of sampling techniques. It can be any subset of the population. So, for example, if the population was all New York State college students, a sample could be NTRIP students. But here's where we get into the idea of sampling techniques. Is that a good sample? Do you think that the students, all of the students at Niagara County Community College would be representative of all of the college students in the state? I'm
No.
saying no, because, I mean, we have a lot of different programs, but we don't have as many programs as other parts of the state. We wouldn't be looking at students who are going into something like fashion and design at like FIT in New York. And we'd also, I mean, most people at NTRIP are from Western New York. We wouldn't be getting the views of people from, you know, like up in the Adirondacks or people from down in New York City or Westchester or Long Island. It would be a very regional view. So that's the idea of, if I wanted to, NTRIP would be easiest for me to use. That's the idea of convenience sampling. I'll sample who's close to me. And that's not always great. It's probably a poor method of sampling. And then there's self-selected sampling. And by self-selected sampling, what comes to mind, does anybody ever, I don't think anybody that's not old like my husband and I, has anybody ever like watched something like the local news, and on the local news they say, okay, all right, we want to hear from you. What's the best fill in the blank in Western New York? And I think at one point in time, my husband was getting like going crazy because I think they were looking for the best pizza in Western New York. And I think the final winner was some obscure bowling alley somewhere in the southern tier, like in Springville or something like that. Do you guys think that a bowling alley in Springville actually had the best pizza in Western New York? Or do you think maybe the owners of that bowling alley had the most relatives who called in? You know, the idea, if a survey is thrown out there and they expect you to call in with your ideas, do most people take the time to call in? Oh, it's kind of like, do you guys ever get in the mail from the politicians that are supposed to represent you, one of those glossy flyers, and it has a big picture of their face on it, and it says, I care about what you think. What do you think about? And they give you like 3 questions and you're supposed to write in your answers and mail them back. Do you guys ever get those in the mail? Do people mail them back? Do most people mail them back?
No.
No. And so the answers that they get, they're only from, like, who sends them back? People with really extreme views. And so they don't get like that general idea. So self-selected sampling, where people who get to decide whether they respond or not, like in those examples, is not good either, because you only get extreme values, only get extreme opinions. And so another example of bad sampling. Are you guys old enough to remember, oh my gosh, I think it must have been almost 12 years ago, the very first time Mr. Obama got elected as president? Can anybody remember way back when?
Yeah.
Yeah.
The day before the election, because there wasn't early voting, the day before the election, everybody said it was so close, it was going to be a tie between Obama and McCain. It was like neck and neck, and it was so close, and it turned out to not be close at all. And so my son at that point in time was working on one of the campaigns. And so when everybody was so surprised that it wasn't close at all, my son told me, he said, Mommy, I knew it wasn't going to be close. But the reason they thought it was because then 12 years ago, when they did the polling to see what people thought, they only called landline phones. Because I think, you know, even 10 years ago, I think there was an extra charge if you try to call a cell phone number or something like that. And so if they were only calling landline phones, even 12 years ago, did most people just use a landline phone? I'm thinking most of the people who had only a landline phone, or most of the people who would answer a landline phone, were old folks, right? And so they were only getting the opinions of an older segment of the population. And so I'm thinking at that point in time, most people 30 or under didn't use landline phones anymore. So it was a very biased result. And if you can humor me for a minute, that's the type of story that I wanted to show you folks from that virtual textbook. I want to look over here at this little article on the side from the Literary Digest. It says, in 1936, the Literary Digest mailed out over 10 million ballots to voters throughout the country. The results poured in, and the magazine predicted a landslide victory of Alf Landon over Democrat Franklin Roosevelt. I think based on this survey, I think there were even newspapers who put together their headlines the night before that said Alf Landon wins. Has anybody ever heard of President Alf Landon?
No.
No. Has anybody ever heard of President Franklin Roosevelt? Yeah. Roosevelt did win. Why were they wrong? Because the mailing list the editors used included people from their own subscriber lists, automobile owners, and telephone books. Well, think about 1936. In 1936 was shortly after the Depression. A lot of people didn't own cars. A lot of people couldn't afford magazine subscriptions. And a lot of people didn't have telephones. It was kind of still a newer technology at that point in time. And so they weren't surveying the general public, but rather a different income group, a different type of person. And so again, that was an example of a bad sampling technique. They didn't get a hold of everybody. They only got a hold of a few people, a certain type of person. So when we're looking at sampling techniques, the best is what's considered random sampling. And something's considered random sampling if every member of the population has an equal chance of being selected. So what does that mean? Let's say I wanted to do a study of NTRIP students. One random sampling technique would be to put the names of all of the students in a big bucket and stir it up and pull 100 names out. That would be everybody in there had an equal chance of being selected. Another would be to go to academic affairs and ask for a list of all of the students and then just pick a random place to start and then take like every 50th name in the list after that, where it's kind of randomly generated. And so random selection is the better way to go. When you look at what your homework questions will be on this, when you look at what the test question is going to be on this, I want to go back to that virtual textbook. And I think I want to go to something like page, I didn't dog-ear this page, I dog-eared a different page. Let's try 780 and see if it takes me close. If I look over here at exercise 1, it says the government of a large city needs to determine whether the city's residents will support the construction of a new jail. The government decides to conduct a survey of a sample of the city's residents. Which of the following procedures would be the most appropriate for obtaining a sample of the city's residents? Do you think surveying a random sample of employees and inmates at the jail, would that be a good way of getting everybody's views on it?
No.
No, there would be How about surveying every fifth person who walks into City Hall on a given day? Do most people walk into City Hall?
No.
No, if they're walking into City Hall, they're probably involved in politics or have a grievance or something. How about surveying a random sample of persons within each geographic region of the city, saying I'll divide the city up to neighborhoods, and then I'm going to pick, 20 people randomly from each neighborhood.
Yeah.
Yeah, that one sounds good. And let's look at the last one. What if I survive the first 200 people listed in the phone book?
No.
No, I mean, if you think about it, only landline phones are in the phone book, so you're missing a lot of people. And then also, if you think about the phone book, it's alphabetical order. The first 200 people, if it's alphabetical order, probably half of them are all related to each other, right? So the C would be the best choice. And so can you see how, yeah, I mean, if we were going to conduct a large study, this idea of random sampling would be important. So, and again, if you read that section of the textbook, it'll go into a lot more detail on it. After you go and sample and collect your data, the next thing that you want to do in statistics is organize your data. And when we organize the data, there's a few ways that we're going to. The first we're going to do is we're going to make a frequency distribution. Frequency distribution. Doesn't that sound fancy? Like it's going to be impressive and important and a lot of work? It really isn't. It's really pretty straightforward. A frequency distribution is a table. In the table, there's going to be one column that lists the data values. And then there's going to be a column. I misspelled column, sorry about that. That lists the frequency of those values. And sometimes there's a tally that you actually use to count the values. So, for example, let's make a frequency distribution of the shoe sizes of people in class today.
Can you scroll up again a little bit? I'm sorry.
Oh, sure.
Thank
And
you.
actually, while I'm waiting for you to get that down, I do know that I let a few people into class a little bit late. And so if you weren't here when I took attendance, could you please give me your name?
Joey or William?
Okay, William, I got you. Anybody else come in late? Did we get Timothy? Alan, did you come in? I thought I saw somebody else come in. Okay, well, our frequency distribution is going to be kind of small. So, can I scroll up again now?
One second, please, actually.
Okay. And I apologize while we're up here at the top. When we organize data, when we make a frequency distribution, it's always important to label everything clearly. And so we're going to make a frequency distribution of the shoe sizes and people in class. Usually I have a slightly larger class and we collect a little bit more data, but we can make it work.
I'm good now, thank you.
Okay, so this would be my title. You always want to put a title on any display that you have of your data, because the reason we're doing is to make this, we're doing this is to make it more readable to people, and they have to know what they're reading about. And so I'm going to have a column for shoe sizes. Then this time I am going to make a tally. And then my frequency will be the important part of this frequency distribution. And it's going to be counting up how many tallies marks I have. Is there anybody in the room who wears a shoe size smaller than 5? So we'll start with 5, 6, 7, 8, 9, 10, 11, 12. Is there anybody in the room who has a shoe size bigger than 12? Okay, now I want to ask you, I want to ask everybody their shoe sizes. I'm going to ask you though, only whole sizes. You know how sometimes when you order a pair of shoes, they don't sell half sizes and you have to kind of guesstimate at the closest whole size. I'll go first. I wear a size 5. Next, looking at this list, Vinny, what size shoe do you wear?
I wear at 11.
Okay, thank you. The next person I've got, Marilyn, what size shoe do you wear?
I wear an 8.
Thank you. William, what size shoe do you wear? William?
Sorry, I didn't hear you. I'm 11.
11, thank you. Sienna?
A 9.
Thank you. Matthew?
I wear an 11.
Michaela?
I wear an 8.
Mackenzie?
I wear a 10.
Kayla?
I wear a 7.
Jaden? Jaden, are you there? Jaden, what size shoe do you wear?
He's got it on mute.
Yeah. Let's see. I think I can unmute people. Jaden? Oh, well. So then the frequency, 1 size 5, no size 6s, 1 size 7, 2 size 8s, 1 size 9, 1 size 10, and 3 size 11s. And does it make sense that having a table like this to summarize the sizes of different people would be more meaningful than just having a random list of numbers? Was it hard to make a frequency distribution?
No.
No, it's pretty easy. I think the title sounds much more intimidating, like the bark is worse than its bite, right? Frequency distribution, we're just making a table, giving our results and telling how often they occur. Sometimes you have that tally in the middle, but sometimes you don't. So there we go. There is one type of frequency distribution that's a little bit more involved, and that's a grouped frequency distribution. And this is something that we might do if we had too many single values to want to list each of them. We put the data in classes. Usually, the classes have equal widths. And so for an example, of a grouped frequency distribution. What I did usually, I start statistics right after we finish probability, and I have a lot of results for the probability exam. But right now, because you guys were able to work on them until midnight last night, I didn't start grading this morning, so I don't have a lot of results. But what I do have a lot of results for are tests, grades for exam 1 sets, for MAT 106, spring 21. And I don't feel like this is violating FERPA at all because there are no names associated with the grades. And also I'm using the grades from not just this class, but my other section too, my other section also. And so I'm going to real quick list the grades so that the data's here. We had a couple hundreds, a 92, a couple 90s, 86, and 80, a couple 85s, an 84, an 82, an 80, a 78, a 75, a 74, 4 70s, a 68, a 67, a 65, a couple 60s, a 55, and a couple 50s. And does it make sense with a data list that looks like that I probably wouldn't want to put each and every number and count how many people got each and every individual grade. And so when I set up something like this, my classes will be the exam grades. And then for each of them, I'd put the frequency. And so I might grade them in groups of 10. I might go 90 to 100, 80 to 90, 70 to 80. But I'm going to stop here because I have issues with this. Does anybody see anything wrong with using those values as my classes?
You used 80 twice and 90 twice.
Yeah. So this is a bad example. We want no overlap. So instead, what might be better for my classes, which would be my grades, might be 91 to 100, 81 to 90, 71 to 80, 61 to 70, 51 to 60, 41 to 50. And now there's no overlap. And so that class from 91 to 100, does everybody see there are 3 scores in that range? 81 to 90, 1, 2, 3, 4, 5, 6, 7, 7 scores. 71 to 80, 1, 2, 3, 4. 61 to 70, 1, 2, 3, 4, 5, 6, 7. 51 to 60, 3, and 40 to 52. When I look at grouped frequency distribution, we talk about a couple of terms. We talk about the lower limits of the classes. And does it make sense that for each class, the lower limit would be the smallest possible number. So for this table, my lower limits, I apologize that 40 should be 41. My lower limits would be the 41, 51, 61, 71, 81, and 91, the smallest number in each possible in each class.
Yeah.
And so those are my lower limits. What do you think my upper limits would be? The highest in each class, 50, 60, 70, 80, 90, and 100. And then we also talk about a class width. And a class width is the difference between two successive upper limits or two successive lower limits. So if I look at my table, by successive, I mean classes that come right after one right after the other. So if I were to use successive upper limits, I might say that the class width for the table above might be 100 minus 90 or 10. Or if I use lower limits, I might say it was 91 minus 81 or 10. What you have to remember when you look for the class width is we subtract this way, up and down. You can subtract either two upper limits or you can subtract either two lower limits, but we subtract up and down. Each class has 10 values in it. So far, so good?
Yeah.
And next place you want to go is stem and leaf diagrams, but I'm looking at the clock on my screen and it says that we've only got 1 minute left, and 1 minute is sadly not enough time to do justice to stem and leaf diagrams. So we'll stop here. Let me make a note that we stopped here. And does anybody have any questions on